need further introduction. Rudolf is going to introduce a possibly new groundbreaking feature for result analysis, and yeah, let's hear about how they implemented SQLite.
Does this work? Okay, I'm holding different. Okay. We had a panel discussion about this, and this is basically about the part that happens before the analysis and after running your simulation. So right now we have this text-based format. First, let's have a recap what we have now. So currently OMNeT have scalar and vector files, and for the content, the files contain the run description, obviously the module names, the scalar names, and the values. Probably some files also contain histograms and other statistical results, and the result attributes, so some kind of meta information like the variable, the parameter names, and similar things. For the vector files, of course, it contains the module, the vector name, and the timestamped vector value. So it's pretty simple. And the original design goal was that the file format should be very easily readable for users, so it could be parsed or further processed with command line tools, which could be quite useful. I mean, if you look into the text file, it's self-describing. What we have regarding tools, we have the analysis tool inside the IDE, which is basically something which should work quickly and easily to show you your first results. And you can also export the data into a comma-separated value file or other formats. We have a command line tool for scripting. It's called the scaf tool. It can also export to comma-separated values and do some other processing steps on the raw data. And we had another tool which is not distributed with OMNeT. It's the R plugin. It's basically an external module into R which allows you to directly read the data into R to further processing. Now, what are the advantages and disadvantages of this format? Obviously that it's human readable, so it's very easy to figure out or peek into that file, and very easy to process it with Perl or Awk or some other tools. The disadvantage is really that either you have to do this parsing yourself, but directly you cannot really, because it's actually this is a format related to OMNeT. You cannot really read into third-party tools without some pre-processing. You can either use the scaf tool or some other scripts that was written or that's why the R plugin was actually created. It's also quite hard to filter out unnecessary data. Sometimes it's very hard to figure out what kind of filter expression I should write to filter out only the data that is related to my experiment. What we are actually thinking is that maybe it would be time to experiment a little bit with different alternative formats. And when we looked around, we figured that maybe SQLite, a binary data format, would be useful in some cases. So what is actually SQLite? It's an embedded database engine. Its main goal was that it should be very simple to integrate into the project. So from the developer point of view, it's just a single C file which we actually link into the OMNeT kernel, and it's really easy to integrate. It has a very good and mature SQL support, so it knows a lot of most of the grammar which SQL is using. It's very robust. Actually, a lot of open source and non-open source projects are using SQLite. For example, all the database and file access inside Android applications, and I believe even in iPhone applications, is based on SQLite. It has a command line tool, so it's very easy to process it from the command line, and it has a lot of graphical tools too, so you can pick your own favorite and start playing with the data. And the main advantage is that it has great integration also with third-party tools, because it's so common. You can actually find ODBC drivers for SQLite files. You can also import directly into R or Python. So the parsing problem is basically solved because you can read the data directly into your favorite processing package, be it spreadsheet program or Python or R or whatever. So it's really convenient. If you check, this is how actually a text-based Scalar file looks like. Like we have some attributes, version number, the Scalar data themselves, and some statistics and fields. So this is how it. Now the problem is actually that it's quite hard to parse these. And here is the database structure of the SQLite database. We have some central tables. These describes the run numbers, and the run attributes. And to each run, we can connect scalars and actual scalar attributes, or the histograms and the different statistical stuff, or vector files, and for each vector, separate vector data items with timestamps and actual value. So it's pretty simple, pretty easy to, it's self-describing. If you import it into a tool, you can even generate these tables. We did actually this to create this picture. So it's very easy to handle, and it's also self-describing. So we have an experimental implementation inside the technology preview, and this is really just a technology preview, so we may change things or even decide that it was not a good idea. It's basically that we need really feedback on this feature, whether it's useful or how this could be used. Actually, it's very easy to activate this feature, because it's implemented as a separate SQLite output scalar manager and SQLite output vector manager class. So instead, just write these lines into the INI files, and everything should work without any further changes. The only additional thing is that the file name for the actual output file is different. It's not so you have to add also yes, the file name attribute is different. It's called not SQLite vector data file, but vector data db or something like that. If you want to experiment with the current implementation, I would recommend to look into the Aloha example, because over there we put a lot of Python scripts and neat things that you can play with. And I would like to continue with some examples how we can use these tools. The first use case is that without any additional change, you can still use the binary files with the scalar tool and also with the IDE. The only difference is that right now it's possible also to write all the scalar files. This is the usual Aloha experiment you may know from the OMNeT samples, and here we put everything into a single SQLite scalar database. So actually the same output can be generated from the binary database. Now the next way how you can use the database is that there are different graphical tools for browsing SQLite files, and like SQLite browser or SQLite man, and actually you can load them into your tool, and you can create, if you know how to write SQL selects, you can also filter your data as you wish, or even if some tools even have some very simple graphing capabilities, like I think this was done with the SQLite browser program, and we wrote a little select which directly generated the same diagram. It's really just for quick experimentation, but it could be much easier to declaratively write a select statement. It's actually an alternative to the graphical way how you are doing it inside the IDE. Now, it's also possible to export the scalar values into CVS files, and this is obviously working also with the text-based files. So the first example works both with the scalar one and the SQLite or the text-based one. We are here actually grouping the data based on names. So each different name, statistics name, will have a different column in the CSV file. We specify that it's a comma-separated value, and we actually give in the database name, and the output is the result. After exporting it, we have also a different way to do it, the SQLite way. The SQLite client itself has an export feature, which also can be used specifying the actual select. You can also create CSV files. Now, what can you do with the CSV files? Of course, you can pull it into a spreadsheet program, and right now we pulled it into Google Sheets, I think, yes, Google Sheets, and we created a pivot chart from there. So the same thing can be done also from spreadsheet program. The next steps could be that if you want some more complicated processing, then a good choice would be some scripting language. Here we tried Python, and from Python it's very easy to pull in the data you have this SQLite 3 package, and actually you can read in all the data, specify a select statement, and then you can further process it with NumPy, SciPy, and create plots with the matplotlib library. It's actually a very nice 2D plotting library. What does it look like? It's pretty simple. We have also examples inside the Aloha example. You just open a connection and then create a cursor, specify an SQL select, and then execute and iterate over the results, and then you can process it like this. This is the charting part. It just goes through on each ISO line, I think, yes, and it creates separate lists for the X and the Y, and then plot them. So it's pretty easy to create these graphs, and we can see the output of the Python library, the same thing, and we have the additional benefit that the matplotlib knows a lot more chart types, so we are not limited to the actual charts which the IDE implements. We haven't done too much research, but it seems that the pandas library could be very useful for Python processing. We would love to hear some feedback from you. What kind of libraries would be recommended or useful for processing the data? We don't really have too much experience on this, but once the data is inside your program, it should be up to you to figure out how to use it. We have mentioned also R. For R, we were thinking you can also read the SQLite data into R. It's a matter of preference what you use. Probably people are gravitating towards Python because it's more general purpose, and you know, if you learn it, at least you can use it somewhere else. So probably that would be the main, but it's really up to you how to use that. Comparison advantages, disadvantages. Obviously, it looks quite rosy. What are the disadvantages? File size wise, sometimes the SQLite files even smaller, so it could be useful, especially if you write big vector files. That could be really different. The vector recording performance itself, however, is somewhat slower, so 2.5 times slower. It really depends how complex is your simulation compared to how much data you write out. So this is really the cost. For read performance, it really depends on the complexity of the query. Sometimes if you write a query which is quite, could be well defined into SQL, it could be rather or even faster. The additional advantage is that after writing the data, if you expect to create a lot of queries, you can also index the data after recording it. So spending some additional time could really lower the recording or the reading time. We have also experimented how to optimize the SQLite database, so we actually are writing out the vectors in batches and also creating separate transactions, so we try to reduce this delay as much as possible. Now the question is whether we should use this or not. It's definitely more accessible, so it's really easy to browse the data with standard tools, and actually it's not it's even, I would say, much more self-describing, because you have the database schema and also the query language is quite well known for everybody, by everybody. The only drawback could be probably the vector recording, but anyway, if you record a lot of data, you have to be much more selective and record only what you really need. But this is only a problem for vectors, because for scalars it's relatively small. Okay, thank you very much. I'm on time, and we would like you to try it and give us some feedback, whether it's useful or not useful. Some things are not yet fixed, and we are experimenting it, like the default values, whether it's better to write into separate scalar files or the same by default. We should figure out those things. Thank you very much.
That's good. Just a quick question: is the technical review going to be released on the website too, or do we have to?
No, it's on the card.
Sticks?
Yes.
Okay.
I think we didn't want it to distribute it into too wide, because you need the context, because it's just hidden inside the Aloha example. So if we publish it on the website, it's just, and it's sometimes the technical preview contains also the demo of the new animation framework, which could also change, or even we are even not sure whether it will go into 5.1 or 5.2 or something. So nothing is settled. So it's more it's a side branch. It's not the main development branch of OMNeT.
Okay. Since we're already at the end of this session, please write down all your questions to Rudolf regarding the SQLite feature. And at the end of the session, let's once again give a big hand out to all our three presenters.